Okay, Rob, should we get started or do you want to wait a little bit longer?
No, let's go. Let's rock and roll.
Great. All right. Well, thanks all of you for joining tonight. My name is Casey Butler. I'm with the San Mateo Resource Conservation District. And I want to also introduce Rob Benetton, who I imagine many of you already know, but who is the Urban Ag Advisor for the Bay Area with UC Cooperative Extension. And before we get started, in addition to the information you all are sharing in the chat, we just wanted to get a sense of who is in attendance. And so we're going to do a quick poll. So I'm going to get that started. And so if you can just respond with, which county are you growing food? And then which best describes you? And if the question about which best describes you doesn't really work for you, feel free to fill that in the chat. Okay, we'll just give it a few more seconds. I think we have almost everybody captured. Okay, I'm going to end it and share the results. So can you all see those results? Great. So yeah, it looks like San Francisco and San Mateo are well represented. One person from Alameda County, and then good representation from the urban farmers, school gardeners, community gardeners, one technical assistance provider, and some curious community participants. So thank you. Helpful just to know who's here when it comes to the information we're sharing. And great. Okay. So let's see. So now you know who I am and who Rob is, and I'm just going to give a brief overview of, there we go. Okay. Brief overview of the agenda for tonight. So I'll give a little bit, an introduction about resource conservation districts. We'll talk a little bit about how the RCDs can provide support to urban ag producers and gardeners and farmers. And then Rob will talk a little bit about UC Cooperative Extension. He will get into the bulk of the presentation about understanding soils and soil health in urban ag. We will have some time for questions, and then we'll also share a link in the chat for the next workshop, which is August 3rd, and that will be about soil sampling and risk or like exposure prevention in urban ag. So with that, I am going to give a brief overview about resource conservation districts. So the RCD was started by farmers in 1939 as the Soil Conservation District in response to the Dust Bowl. Today, there are about 100 RCDs throughout California, and they exist across the United States as well. And we exist in close partnership with our federal partner, the USDA Natural Resources Conservation Service. And we started working with farmers and ranchers, many decades ago, and expanded to work with all landowners and land managers. And so just to give you a little bit of information about what we do and how we do our work. So the RCD is a special district like a fire district or a water district. So we are local government, but we like to just clarify that we are not part of the county government, although we work closely with them. And we operate like a nonprofit. And we exist to help people help the land, and we do that in 3 ways. So the first is by providing technical assistance, which is free and non-regulatory. And we also implement conservation projects. So anything from building ponds to helping farmers plant cover crop. And the third is conducting outreach and education, kind of like tonight. And although we started specifically as a soil conservation district, our scope has expanded to encompass all natural resource areas. So this gives you a sense of our different program areas: climate, agriculture, water, wildlife, and fire. And I encourage you to check out our website if you haven't heard of us before or want to learn more. I think Audrea might put our website in the chat, who also works at the San Mateo RCD and is in attendance tonight. If not, I can share that later. But I encourage you to go there to find out more information about the work the RCD does. And then also, I think she shared a link so that if you aren't in San Mateo or San Francisco counties, you can find your local RCD. And then how we can help you. So just like tonight, we have educational opportunities, and this has all been provided through funding from the National Association of Conservation Districts. So we're able to put on this workshop and offer assistance to our urban ag growers. Some of the ways that we can help you, other than the workshop tonight and in 2 weeks, we can also provide technical assistance. So like we mentioned in our intro, the RCD provides free non-regulatory technical assistance. And if you have questions about your natural resources, so water, soil, wildlife, habitat, we can set up a site visit and see how we can support you in your questions or curiosities or needs. And occasionally we have funding to support conservation projects, like those that build soil health or establish composting setups or pollinator habitat, or a wide variety of other potential projects. And if we can't help you, we'll try to connect you with someone who can. So quickly, if anybody has any questions about the RCD or some of that like technical assistance we can provide, we can answer questions now if anybody wants to put those in the chat. If not, we can definitely find time towards the end of tonight to talk about that. Okay, I don't see any questions. So I'm going to pass it off to Rob to share all that he has to share. So I'm going to stop sharing, and then Rob, you can bring up your presentation.
Hi, everybody. How are you? Give me 1 second here. What is this? Ah, okay. And slideshow. All right. Good evening, everyone. My name is Rob Bennett, and I work with UC Cooperative Extension. And I'm the Bay Area Urban Agriculture Advisor. Can you give me a thumbs up if you can hear me? All right. Thank you for attending. Thanks, Mishwa. In the Bay Area, we've been operational for over 100 years. We're the Applied Research and Education arm of the University of California. We sit within the Division of Ag and Natural Resources. And some of the other programs you may also be familiar with might include 4-H, Master Gardener Program, Master Food Preservers, Livestock and Natural Resources Management, Weed Science, and Integrated Pest Management, just to name a few. And we are housed in our county agencies, so we wouldn't be here without the support and help of our local counties. And they largely house us and provide some infrastructural support with which we're able to operate and use applied research and education to help solve locally identified community-based problems. Thanks so much for having me on this webinar today. So today we're going to talk about improving your soil quality, ultimately for the urban food grower. Understanding your soil quality in the urban farming process is very, very important. It helps us ultimately get to healthy harvests and bountiful blooms, right? And so soils, in short, form over millions of years, right? Large portions of the United States was covered by glaciers in many parts of more ancient history. And over time, that glaciation and weatherization process eroded particles off of our geological formations, our rock formations. These included actual rubbing off of the rock, so you got particles that would fall over time and run with the water. And so the kinds of geological formations we have in our local geography, our local regional natural areas, ultimately very much affect the particle size, the actual kinds of particles that we have in which we ultimately are able to potentially grow crops or flowers or other kinds of plants. And so in thinking about the kinds of geological formations in the soil formation process, and this alone could be easily its own entire undergrad or graduate course, right? We think about the three main types of geological formations: igneous, metamorphic, and sedimentary. And in this process, in igneous rock, we're talking largely about what formerly was at one point volcanic in origin, right? Metamorphic, we are talking about a geological formation that changed its structure over time due to a great deal of pressure. Those who may remember Christopher Reeves in Superman may remember when he squeezed a piece of coal with a great deal of pressure. And what did it become? It became a diamond, right? So it's that degree of pressure. And then sedimentary rock often is found more under oceans and waterways, where there was a large waterway on top of it, and you had sediment accumulation over millions of years as well. And all of this particle size and density originating from the parent materials also is affected over time by temperature, pressure, and the weather in the local area combined, right? So here's a basic concept. We're going to talk a little bit about something called aggregate stability. And I'm going to ask you to stay with me during the course of this presentation, because there may be times I ask you to actually pronounce some words we talk about too, okay? So it's not just a listening session, we're having a conversation over time, okay? So we're going to talk about aggregate stability. Can everybody say the word aggregation? Aggregation, okay. So in thinking about aggregation, you're thinking about how well a soil holds together when it's wet and how well it holds together when it's dry. And a lot of what goes into the stability of a clump of soil in your hand, right, is the particle size, the pore size in between those particles, and the organic matter. So let's unpack that a little bit, right? Particle sizes are varying by types of, again, the parent material, the geological formations. And then we'll get into that a little further in a hot second, but pore sizes, when we think about pore sizes, we're thinking about that space that is often also occupied by either air or water in the course of the soil matrix in that growing area where our plant roots are growing. And so I ask you to take a deep breath, okay, because we're going to get into why air is so important for plant growth in a second as well. And then organic matter. We're going to go into defining organic matter shortly. Now, think about this imagery we have here. We've got some layers, and what these are called are soil horizons or horizonation. And you can see from the two visuals that at the top, you've got the A horizon, the topsoil, right? The subsoil, often the B horizon, going 12 to 36 inches potentially, but it also depends on where you are. And then the parent material, the C horizon, followed by the bedrock, right? Now, in an urban area, oftentimes it's these soils that have been disturbed, and you often wind up having, especially that first A layer, that top layer that can be 6 to 12 and even 18 inches deep, depending again on where you are, right? Actually removed during the course of construction, during the course of development of a sports field, during the course of digging out the soil for the foundation potentially of a building, right? And oftentimes in the process of urban development, that soil gets partially or fully put back in some ways, but it's no longer the way it was, and it's now been disturbed, right? And so we often wind up as a starting point in most of our urban areas, starting with subsoils, that B horizon layer, just to begin with. But in that A horizon layer is that OM, that organic matter, okay? And we often think in terms of organic matter, in terms of the National Organic Program. We sometimes think about it in terms of what we get at the supermarket, whether it's organic produce or not. But when we're talking about organic matter, what we're really saying is something that is or was once alive. So I'm going to ask everyone if you can unmute and repeat after me. Organic matter is something that is or was once alive. And of course, we're in a webinar, so you may or may not be able to unmute, but we welcome your participation. So here's your goal, okay? I want you to think about this, feel it, think about what it would feel like to touch this clump of soil in your hand, okay? Your goal is to have a rich, dark, crumbly soil that holds water well when it's wet and also lets it go at a steady pace, a steady rate over time as it dries, okay? So that it can also provide plenty of healthy nutrients and capacity for holding water for the plants to grow their roots through. So what are the 4 things plants need, right? We often think about soil and when we're growing crops, but we don't always think about it in terms of basic mechanics, right? What are the 4 things plants need? So we know water, right? That's often the first one folks think about. And we know also they need energy to grow. And where do they get that energy, right? They get that energy ultimately from the sun. And then they need nutrients, right? And nutrients are often thought of in terms of chemical elements called macronutrients or micronutrients. And I want you to think about what that might mean in terms of the needs of the plants, right? Micronutrients sounds like big, or does it sound like small? Well, we know from microscopes or microbiology, right? Micro often refers to something smaller. And in the case of micronutrients, those are nutrients that are needed in lesser frequency and or lesser amounts by our plants in order to be healthy. And macronutrients are those nutrients that are requiring to be utilized for growth in greater amounts and in greater levels of consistency for plants to grow in a healthy manner. And we also need macro and micronutrients too, right? In our bodies as well. Calcium, iron in our blood, in our hemoglobin, right? It's the core molecule for hemoglobin. Magnesium, sulfur, and calcium are the second 3 of the macronutrients, and nitrogen, phosphorus, and potassium are the first 3 of the macronutrients. And these start to sound similar because they also reflect that old saying our parents used to tell us, you know, you are what you eat. Oftentimes, you can actually identify certain particular nutrients from certain foods that we need in order to grow in a healthy way. And then what's the 4th thing, right? Well, folks don't always think about plants requiring oxygen in the same way that they think about plants requiring water and energy and sunlight. From sunlight providing energy, right? But in particular, oxygen is needed around a certain part of the plant. And that becomes really important later on as we get into this discussion. But for the purposes of here, again, I want everyone to take a deep breath. Think about the part of the plant that actually oxygen might be needed for, right? We know from our basic botany and science classes growing up that the opposite of photosynthesis is respiration. And so plants require oxygen around their root zone, in particular for the respiration process as well. So soil is made up of a matrix. Think of a pizza pie, right? A variety of slices of the pie, right? You've got your mineral particles, those parts that we were talking about earlier, where geological formations were weathered and eroded over time. And in the case of glaciation, often the melting of glaciers resulted in those particles flowing to other spaces and places, usually carried by either ice or water, right, in geological history. Then air and water, right? And air and water are usually that which is within the pore spaces, those open pore areas that are in between those mineral particles, right? And then you've got the slice of organic matter, that part, that component, that's usually the smallest amount, but is often one of the more important components of healthy soils. And in most average soils, you may find around 5% of our soils are organic matter. And when we're talking about organic matter, remember, we already shared organic matter is something that is or was once alive. Here we're talking about living organisms, plant roots potentially, right? And those living organisms can be insects also, and they can also be microbacteria and fungi, right? Mushrooms. And then what's called humus. Now, don't get this mixed up with hummus. Hummus is that Middle Eastern food we often use as a snack at our social gatherings, but this is humus. Humus is not exactly compost. What it is organic matter that has decomposed up to a point where it is no longer decomposing at a rapid rate. It is no longer gassing off. You will generally not see smoke coming off of it, and the pile will generally not be hot. So usually it's well past being compost and has fully stabilized in terms of temperature. So soil is a matrix of all of these things in terms of minerals, organic matter, air, water, and living and not living organisms as well, and the humus that remains. Here's another image of the same set of concepts, except in the actual form of what it looks like in the soil itself. So as an example, we have quartz particles here and some clay particles, some air and some water, and some organic matter. Now, these quartz particles, as well as right on the fringe of them where the air is, right, where that organic matter is, there's some colonies of bacteria, right? And there's also a level of complexity here because the microorganisms that we might not be able to see are actually interacting with the air and water in that environment, and also interacting with the clay and organic, clay particles and organic matter, right? Clay particles and organic matter have a tendency to have a small negative charge on them. And this is one of the things that becomes important later when we start to talk about something called cation exchange capacity, which helps for nutrient exchange with plants and specifically with plants' roots. So we're going to get into that shortly. But before we do, we need to talk a little bit about particle size. So all soils are generally made up of varying particle sizes. You've got sand, silt, and clay. Now, on the left, you've got what looks almost like a boulder in this image, right? Gravel. But for the purpose of this discussion, we're going to just imagine that gravel piece is not there. Think about a river. And as a river carries particles, right, downstream, what falls out first, right? As a creek or a stream or a river carries those particles, what might fall out first? Well, it might be the heaviest things, right? The gravel first. And then eventually others like sand, silt, and clay. So I'm going to switch out of this and show you a little, a little video on this piece. Give me 1 second. I'm gonna queue up the video. And this is gonna be about 5 minutes. Hang on. Okay, and I got to share screen. Sorry, this is a little bit. Okay, here we go. So in thinking about the particle sizes, this is a little simple exercise we can do at home. And what you would do is you would buy a quart size jar, glass or plastic. Of course, glass is more sustainable, right? Recyclable. And you would go ahead and go through this exercise. So I'm going to put this on and play.
Yeah, Rob, the sound isn't working.
Oh. Oh, that's interesting. Okay. Well, so if the sound isn't working, I'm just gonna keep playing that's weird. I don't know why the sound isn't working. But what he was saying was that good, healthy soils are a nice, well-balanced mix of sand, silt, and clay, often called a loam. And so when looking at your soil, you want to actually interact with your soil. You want to pick it up, hold it, feel it. Is it rough? Is it smooth? Is it gritty, they say often, right? Does it hold together well when it's wet? Does it hold together well when it's dry, right? So what he's beginning to do in this video is he is going through a series of tests, actually. And these are among the first of what are called indicators. So we use indicators to help us understand, to assess our soil quality. Indicators actually indicate to us what the quality of our soil is and give us some assessment understandings of how to possibly improve our soil over time, right? And so he is first doing what's called the soil ball test and also the ribbon test over time. And so you can see he has taken the soil in his hand, he has wet it and kind of massaged it over the course of 3 to 5 to 10 minutes and attempted to form what's called a ball, a soil ball, right? And it can be the size of a ping pong ball or a golf ball, for example. And then over time, what he did was he took that ball and he actually squeezed it into a more flattened kind of formation. And as time goes on, with some level of clay in the soil, that soil will actually begin to form the shape of your palm in your hand over time. And we can use what's called a dichotomous key to help us understand what the proportions of sand, silt, and clay in our soil might be, and eventually get into this test called the soil sedimentation test. So he's taking about a third to half of that quart-sized bottle and actually putting it into the soil. Notice he didn't really break it up all that much. Later on, you can see he does, right? And he has actually then filled the rest of the jar all the way to the top. Okay. And then the idea is you seal the jar tightly. Keep in mind, whether this is a plastic jar or a glass jar, the likelihood you're going to use this jar for anything else in the future is probably on the lower side, right? So this can be an opportunity for you to actually use the same jar at many different locations if you grow food or flowers at many different locations, right? And so as the particles settle, what do you think might get settled first, right? Think about this over time based on the particle size, right? We had gravel, of course, but then the next would be sand, right? And you can see that sand layer right there that formed, right? And usually the sand layer will form in like 30 seconds to a minute, right? And then the silt layer will form in more like 3 minutes, right? And even up to like 10 minutes perhaps. And then if you wait 30 minutes, even up to a day, you will start to see the rest of the soil layers as well. So I'm going to switch out of this and go back to the PowerPoint. Give me 1 second. Okay, so we're back. So, whoops, the first of the tests in this case was the ball test and then the ribbon test, right? You take a ribbon and you hold it into your hand after it's originally been formed into a ball. You kind of, again, you might have to spray it with some water, but you're gonna flatten it out and you're gonna, it's a very therapeutic process. You're gonna try to rub it right over your fist over time, right? And how well a soil aggregates will also be indicated by how well it holds together over your fist without falling off of the outside of your fist, okay? So soil porosity is the percentage of a soil that is pore space or air and water, and the average soil has about 50% porosity, and sands have larger pores but less total pore space than clays. That's why clays often can compact a great deal, right? And you'll often see footprints in high clay soils that become very hard because they have less overall pore space. So I want you to think about air and water movement, right? I want you to think about the soil just when you use your naked eye, okay? In terms of that first set of indicators, we talked a little bit about the ball test and the ribbon test, but also think in terms of what you see visually, right? As a generalization, the darker the soil, oftentimes the more organic matter or the richer the soil is. Now, that isn't the case in every instance, but it is very often the case. It is a regular pattern, right? And in terms of plants' growth, it is very, very important to think in terms of water and air movement, right? How does water and air move through soils, and how easy then is it for plants to uptake that water and to grow through those pore spaces and to respire, to uptake some of that air around their roots, right? So how does structure affect water movement in soils? How does soil structure affect water movement, right? Ultimately, a good soil structure has decent sized pore space. Pore space is large, which allows for good air and water flow. A well-developed structure is very important, especially in clay soils. Clay soils with a poor structure are less likely to allow air and water flow. And that becomes a problem for plants in terms of their ability to grow through the soil, but also in terms of their ultimately becoming more water-bound, right? Overly inundated with water, and ultimately that can very much affect the health of the plants, right? So we talked a little bit about the color of the visual test, right? A darker soil tending to have more organic matter and being of a better quality. Soil texture, the texture by feel, right? The ribbon test. Soil sedimentation or suspension, that's the percentage of sand, silt, and clay in the soil. And also want you to think again about what's called the ball test as well, okay? So Soil texture is the single most important physical property of the soil. That there on the upper right, that image right here, that's a ribbon, right? How well the soil holds together as you're sort of rubbing out that ribbon over your fist and over your fingers without it falling off is going to be very much an indicator of the quality of your soil, how well it aggregates. Again, everybody say the word aggregation, right? So soil texture helps the grower understand water and holding capacity, the potential of the soil in terms of fertility and what your fertility program could be. And also if you're about to develop some properties, suitability for building and construction. These are other images of the ribbon test, right? And you can see on the left, that lower bottom set of images on the left side, right? The soil didn't hold together as strongly and that ribbon fell off, right? Whereas in the middle and the right side, the soil with a little bit more clay or a little bit more organic matter in it actually held together longer and better and hung off of the person who's doing the soil ribbon test off of their fist without it falling off. And that's a really good indicator. And that's a ribbon test is a test you can do at your garden or farm site in the field at your urban farm. All right. So we're going to dive real quick into the soil sedimentation test and instructions as well, right? What you would do is you would take a quart-sized bottle, as you saw there, and you would fill it about halfway with soil from your local urban farm or garden space, and you would fill it with water all the way to the top and seal it well. Remember how some of that was leaking in the video, right? You don't want that to leak on you or ultimately on your family if you're having your kids take part in this exercise, right? It's a fun thing for kids to take part of as well, right? And you're gonna shake that bottle for a couple of minutes, okay? And then you're gonna set it down and you're gonna wait 30 seconds, 3 minutes, and 30 minutes or up to a day. And you're gonna see how the layers form, okay? Now I'm gonna try to switch over to the other video for one quick second, excuse me. All right. So. All right, so we're gonna put the video at the start and just take a look at this for a second. Okay, so they were doing the same exercise, right? They were trying to get a sense of how well the soil would hold together when it's wet, how well it would hold together when it's dry. Can you form a ball, right, with the soil itself? Does the soil start to take the form and shape of your palm, of your fingers, right? Smell the soil. Does it smell sweet? Does it smell a little off-putting, right? Is it smooth? Is it gritty, right? And then squeeze upward to form that ribbon, right? Allow the ribbon to potentially break a little bit if needed, right? And it's, again, very much a therapeutic exercise. It's something you can do in the field, in your farm and garden space, right? Sandy, loamy soil will, a loamy soil will hold together much better than a soil that has far more sand, generally speaking, which will fall off, right? And you can see that ribbon on the right-hand side forming, right? You can see it actually hanging on without falling off. And if you were in very, very fertile soils, places like the breadbasket of the Midwest or the Central Valley of California, that soil would hang off of your fist and potentially even beyond the height of your fist without falling off. Quite amazing. soil is in its ability to hold water, to hold nutrients. And the physical structure, how well it aggregates, is going to be very much what tells you the quality, the physical quality of your soil is, right? And then ask yourself again, is it smooth? Is it gritty? Is it smooth like a flour for comparison, or gritty like sand, right? Is it a little bit of either, right? And how does that affect your ribbon, right? In a sandy loam, you're going to have more grit, and that ribbon's going to fall off, actually, right? Whereas in a silty loam or even a clay loam, you're going to have a smoother ribbon. It's also going to kind of stick to your fingers more and to your hand, right? The more clay in the soil, the more it kind of sticks to your hand. And it's harder to rub off without like a brush, right? A nail brush. So keep this in mind. This is going to give you some really good sense of ultimately your physical soil quality, right? So I'm going to switch back to the PowerPoint. Okay. So all right. In thinking about the soil sedimentation test, right? We saw the layers form. We noted that sand falls first, right? And then after 30 seconds, that's the sand. In 3 minutes, you then have silt. And then in 30 minutes or more, you have clay fall out of solution. On the top, for a long time, you will have a very thin floating layer. That layer is organic matter. That is the organic matter that is or was once alive in the soil, right? And it's the balance of all of these that you're after, right? If you have too much clay, the potential for reduced water flow, that's okay, sorry about that. That was unusual. All right. Okay, so when you get your layers formed in your, oops, you all are not seeing me because I wasn't sharing. Okay, all right. Okay. All right. So this is the soil texture classification triangle, right? The idea is to have a level of balance, right? How much clay, sand, and silt you have will very much affect how well air and water flows through your soil. Sorry about that earlier. Okay. And what I would say is this. I say balance because having too much clay can restrict the amount of air and water flow through your soil and then affect your plant's health. And having too much sand can actually let water drain off very rapidly and not provide enough time with which your plants can uptake that water and or the ability to hold nutrients and uptake those nutrients as well. So you would take a ruler and you would actually measure the height of that jar, and you would then put it over that number, that height, over your total height of all of the layers, and you would get what's called a fraction, right? You would get a numerator, the height of the one layer over the total height of all the layers, and you multiply it by 100 and you get a percentage of sand, or in this case silt, percentage of clay, percentage of sand, right? And then you would follow the grid lines, these sort of not as dark grid lines here, and you would get a sense of what your soil texture classification is. It is perhaps a sandy loam, or is it a sandy clay loam here more in the middle with less silt, right? Or is it a silty clay loam, right? The word loam tends to mean more of like a mix, an intermixed set of the various kinds of sand, silt, and clay, okay? So we're going to dive into chemical indicators of soil quality also. Chemical indicators include pH, and folks often refer to the pH scale, and specifically that the pH scale is a scale of 1 to 14, but in reality, it's actually 0 to 14. And then another chemical indicator of soil quality is cation exchange capacity. So in thinking about soil pH, one often thinks about whether a soil is alkaline or acidic, okay? Folks that have, in many cases, folks that have grown up in parts of the South have sometimes referred to soils as being sweet or sour, right? That's an alluding, a reference to soils being more acidic or more alkaline. Here in the middle, right between around a 6.5 to a 7 or a 6 to a 7 is the most ideal for plant growth. Now, this particular diagram gives a 5.5 to an 8, but really neutral is about a 7 or a 6.5 to a 7, okay? Anybody here like to eat blueberries, okay? Blueberries are one of those crops that often folks like to have with their breakfast in the morning. But blueberries are also one of those crops that like a particular type of soil pH. They like it slightly acidic, more like a 5.5, right? Whereas goji berries, on the other side, tend to like it more like a 7 or a 7.5 in here, slightly more alkaline soil. And what are some foods that are acidic or alkaline, right? In thinking about foods that are acidic or alkaline, we're thinking about things like milk, right? Maybe baking soda for baking. On the acidic side, all citrus, right? Sodas, coffee, those kinds of things, right? So soil is a measure of acidity or alkalinity of a soil, but this becomes important because right near that neutral zone, that's where plants can uptake the most nutrients, right? So I want you to think of it this way as an additional thought, right? pH, soil pH is measured on the pH scale. And this image is also the pH scale, except it's not from 0 to 14. This is truncated, right? We've cut it shorter. A soil with a 4 up to a 10 is the range in which we're looking at the absorption of the macronutrients we talked about earlier and the micronutrients. Now remember, we said that macronutrients are those nutrients that are the most needed by plants in the most consistency, frequency, and amount, right? And then the micronutrients are those that are lesser needed in terms of frequency, consistency, and amount, right? And you can see right here between the 6 and the 7, and especially between the 6.5 and the 7, the majority of these nutrients are actually the most available to plants in these soil pHs right here, okay? And so this becomes important as you think about your fertility, as you think about your soil pH, as you think about the ability for your crops to uptake nutrients over time, right? And when we talk about fertility, folks often will see on the bag of a fertilizer 3 numbers like these 3 right here, the 10.6.4 and the 23.23.0, right? And for the purposes of this webinar, right, what I want you to take away from this understanding in terms of the macronutrients we just looked at, right? Here you have 6 macronutrients and 5 of the micronutrients. And yet here, these numbers are really only talking about 3, right? So on a fertilizer bag, if they're only indicating these 3 numbers, right, as their main point, are they giving you the whole story, right? Because you want to understand all of your plant's needs and all of what might be in a fertilizer if you're going to use fertilizer, right? So just keep that in mind as you get your soil tested, as you think about soil testing over time too. Now, in terms of the second part of indicators, the second part of chemical indicators of soil quality, right? We have something called cation exchange capacity. Cation exchange capacity is very simply a measure of a soil's negative charge. Remember, I mentioned earlier to you that Clay, as well as humus or organic matter, right, has some level of negative charge on it. And most of the macro and micronutrients, not all of them, but most of them, are actually with a positive charge. So having some level, not too much clay, and certainly having some proportion of humus or organic matter in the soil will very much help keep your soil healthy, and ultimately help with soil absorption. But everything in balance, right? So you don't want too much clay or too much sand, and you don't want to just grow crops in just compost or humus, right? But having balanced proportions of these will actually help for nutrient exchange around the roots, and good soil to root contact, so that your plants can uptake nutrients over time. And these are root hairs doing exactly that. So basic concept here, right? Organic matter in clay, which has a large surface area and some level of a negative charge, right, will help with actually having a good soil fertility, right? Ultimately having a fertile soil, a healthy soil, right? If you have too much clay or too much sand, you're a little bit off balance. If you take sand and you mix sand with clay, you're creating some of the early historical forms of what today we call concrete, right? Can plants grow through concrete, plant roots? Very few really can break through concrete, right? So that's a very, very hard structure. So adding organic matter and having some clay in the soil will ultimately produce healthy plants. They will be able to uptake nutrients and water well, and ultimately, or adding organic matter, adding compost over time will increase the proportion of cation exchange going on. The proportion of organic matter will increase cation exchange capacity, okay? So what is organic matter? We talked about it being something that is or was once alive, but I often refer to it as honk, like honk your horn, right? Organic matter tends to have a carbon skeleton, like our vertebra, that holds us up, right? And then various elements like hydrogen, oxygen, and nitrogen, just to name a few that branch off from them, right? So adding organic matter over time will help with our soil potential. And this is an image of a healthy soil with a good, healthy microbiological life, a good fungal network, right? As we add compost a little bit at a time, right, to our soils through top dressing, through amending, right, we actually can increase the amount of microbacterial life, the healthy bacteria, and the healthy fungal life in our soils. These can be really important, especially in high clay soils, which often in some parts of California are very prevalent, right? So your goal is to have a healthy soil that has some nice balanced proportions of organic matter in it, some fresh residue, like for example, from cover cropping, organic matter that is decomposing, right? Cation exchange capacity will increase your soil fertility. It'll very much increase your capacity to hold nutrients and water over time, and is the second of the soil chemical indicators. Again, your goal is a dark, rich, crumbly soil that holds nutrients well when it's wet and lets it go slowly over time as it dries, allowing the plants to uptake some of that water and some of those nutrients. And then soil quality is also based on the biological life of the soil, right? Think in terms of pill bugs, bacterial life, worms, centipedes, millipedes, right? Keep in mind that having plenty of air in the soil will help with the biological life. You don't want to scare the micro ecosystems, right? Soil biodiversity is really, really important. Having a healthy soil biological life will ultimately also help your plants to fight off plant diseases as well. So this is a microscopic blow-up of a root-feeding nematode trapped by a fungus, right? That actually was going after it because it was also going after pepper crops. Then think about limiting factors for plant and soil health, right? One limiting factor for plant growth is nitrogen. Nitrogen is the core macronutrient, right? We look in that fertilizer bag, we saw that it said NPK, those 3 numbers, right? But nitrogen is that limiting factor for plant growth that's the most important. And it's easy to, in short periods of time, limit by accident nitrogen by having almost too much carbon in the soil. In some garden bed and urban farming situation, sometimes we use what we can access easily, what's cheap, what's affordable, right? Sometimes we have a lot of access to wood chips, and we may want to wood chip our soil beds, our beds where we grow our plants for a variety of reasons. But when thinking about growing crops, especially vegetable crops like our roots and our leafy greens and our stems, right? You may not want to use wood chips to mulch because you're adding carbon as a mulch layer, which could tie up some of the nitrogen a little bit over time. It won't tie it up forever. It will release it, but temporarily having some level of wood chips covering the soil can actually hold nitrogen and reduce the amount of plant available nitrogen. So think in terms of mulching, but think in terms of mulching with straw instead. And on the East Coast, we would use hay. On the West Coast, we tend to use straw, right? Straw will keep the weeds down and keep weeds ultimately from germinating, from reaching into the sun, right? And also will help the soil to hold water in place as well and reduce potential for runoff. So think about using wood chips for pathways, right? Wood chips are great for keeping weeds down in pathways. They will reduce the likelihood of weed germination and smother the weeds ultimately, right? In terms of soil fertility, think about cover crops, right? If you add cover crops in the fall to your soil bed, you can let them grow over the course of the winter and cut them back right before they're flowering in the late winter, early spring. These will help hold the soil in place during the winter rains. And as you cut them back, you can take a broad fork and just poke into that soil and just do what's called the wiggle, right? Now I call it the wiggle, right? We haven't talked a whole lot about tilling or no tilling, but over time, you want to reduce the amount of disturbing of the soil you do, right? In the beginning of your preparation of the soil, especially the very, very first time, right? If you're starting a new urban farm, you might want to turn the soil a foot or 2 down, right? Or easily 12 to 18 inches, right? Think about what you might find, right? In urban areas, because soils are disturbed and there's usually a history, I have run into all sorts of things. I've run into iron rods, plastic bottles, beer bottles, plastic PVC piping, garbage bags that were buried, occasional car parts, batteries, right? So, be observant, know what you're running into in the soil. Maybe keep a list of what you run into. Okay, but that first time you're prepping the soil, for the very first time, it's okay to turn the soil. Over time, you want to reduce the amount of times you turn the soil because you want to reduce the amount of disturbance you undertake with the soil. Okay, and also think about food safety and think about manures, right? Oftentimes we want to apply manures. What kind of manures do we use? We tend to only want to use herbivore manures. And we want to provide a solid 120 to 160 days between if we're adding manure to our soil and when we're planting, okay? There's all sorts of implications of using manure if you're an organic grower, if you're certified to be organic. And that would be almost like a whole other set of topic to discuss. But the reason you're going to allow for a period of time when applying manures, if you're going to your soil beds, is that you want to keep you and your family and your consumers and your crops ultimately safe, right? First of all, fresh manures are very hot, but second, the potential for food safety pathogen entry and contamination is much higher the earlier you're incorporating, and actually the sooner you're planting. So you want to give it a nice period of time. Most folks find it easier and smarter to simply add herbivore manures to your compost, right? And then we get into compost a little bit. There are lots of different kinds of compost. You want a well decomposed, no longer hot, stabilized temperature compost. It's called a finished compost. And it's kind of moving towards that phase of where it becomes humus over time, right? It's no longer smoking or gassing off. And you can have leaf-based composts, like from deciduous tree leaves. You can have food scrap compost. You can have worm bins that can be helpful to your growing processes. Or you can have composts that have some level of manure in them as well, right? And then think about fertilizers. When we think about fertilizers, one of the things we want to think about is water solubility and versus water insolubility. And also thinking about synthetic fertilizers, we want to understand what went into the process of making it, right? So when we think about fertilizers, think about water insoluble fertilizers as being slow release fertilizers. And that's your main goal. If you're going to use a fertilizer at all, use low dose fertilizers, maybe a 5-5-5 or a 10-10-10 in terms of the nitrogen, phosphorus, and potassium. But you want it to be a slow release over time, okay? And when we're thinking about synthetic fertilizers, we want to think about the process of what it took to make that fertilizer. Synthetic fertilizers often require a number of chemical reactions, and fossil fuels are often required in order to make those chemical reactions happen. So there's an embedded amount of energy expended in the process of creating synthetic fertilizers, okay? Think about soil in terms of that air that's needed around the plant's roots, right? If you step on the soil, especially your veg crops, right, that have those softer, tender roots, right, closer to the plant itself, you have the potential for reducing root penetration and water infiltration over time, right? So build up, build raised beds, right? Even if you're not doing planter boxes, build upward. Okay, your local soil temperature will increase faster in the spring and get cooler, slower in the fall when you have raised beds. It'll be closer to ambient air temperature. So think about your crops, right? Your summer crops like warm feet, especially tomatoes and cucumbers, things like that, right? And actually, ultimately, that temperature will very much affect the rate of plant growth as well. So try not to step into your beds. Keep your veggie beds, especially, not super wide, right? Think about putting pavers down where you do need to step into your beds so that you're not compressing or compacting the soil. And then mulches, right? We talked a little bit about straw. We talked a little bit about wood chips. But the main idea is smothering the weeds, reducing weed germination, and ultimately increasing water absorption. Mulches can also reduce upsplash too over time. So this here concludes this webinar. And I wonder if anybody has any questions. And I just want to wish everybody a happy and safe growing. And please do stay tuned to our next webinar, which will be on August 3rd. And I know Casey will or has dropped a link into the chat. So at this point, I wondered if there are any questions that have been placed in the chat.
Any in the chat yet. If anyone is interested in asking a question, we can unmute you. So either write your question in the chat or you can raise your hand and we can unmute you. And we have a question about, Rob, what does your hat say on it?
Champions for Change, Network for a Healthy California, or NETA. The Nutrition Education Training Academy was a program of UC Cooperative Extension in the 90s into the later 2000s, and it was a federally funded program. Today it's part of a suite of what are called SNAP Ed programs, or supplemental nutrition assistance program educational opportunities that are often offered through the land grant university system. Other questions related to soils?
Yeah, there's a question from Yolanda. It says, sources of soil if you are using raised beds. I need more mineral matter.
Ah, okay. So first of all, don't just take any body's soil, right? Sometimes you will run into landscapers who are very, very happy to let go of their free topsoil, right? If you've not tested your soil yourself, or that topsoil yourself, and had it sent to a lab, right? You probably may not want to take that topsoil until you've gotten the test results back, right? There are some vendors that do sell topsoils, as well as what are called OMRI certified composts. We cannot recommend any one vendor, as the UC Cooperative Extension Urban Ag program, or even the Master Gardener program, if you're connected with or asking questions of the Master Gardeners. But there are a variety of landscape sources that do provide some decent topsoils in the region. And so I would say use Google and look it up, and think about where small growers are getting their topsoil, if they're growing any. But the reality is that on an urban farm situation, often folks are more likely to import compost than they are topsoils. Other questions?
Okay, we have one more that came in about the ribbon test. Would a clay soil also hold together, and how can you differentiate it from a balanced soil that also holds well together?
Certainly. So when you do, this is actually one of the many reasons I tend to like to do this webinar actually in person as a workshop, right? Because you get folks to be able to come near together, and they actually get to see the soil sedimentation layers. So first of all, a soil that's high in clay will have a tendency to have a good strong ribbon that holds together well. But remember that too much clay can restrict air and water flow. So you want, as with everything in life, a nice balance, right? So a clay loam is a nice, good soil to start with. What you don't want to do is add sand to clay soils, or clay to sandy soils, because then you have the potential for them to bind up and have very, very, very tiny pore spaces as a result, and hold water excessively well, and harden off when they dry off to the point of being like a rock, almost like concrete. And then, can you go through that second part of the question again, Casey?
Yeah, I think you got it. It just asked about, would a clay soil also hold together, and how can you differentiate it from a balanced soil that also holds well together?
Right. So that soil sedimentation test with that with the jars, right, that you can do in the field with a quart-sized bottle, right? And in the fact sheets and tip sheets that Casey's going to share at the end of the webinar, there is the soil sedimentation test and the instructions to actually follow, right? But you would take the jar, fill it about halfway with water, with a nice big handful, or even a handful and a half of soil. Fill the rest of it with water. You're going to shake it for a minute or two, and then let it sit. In 30 seconds, the gravel, if there is any, and the sand will fall out of solution. In 3 minutes, the silt will fall out of solution. You'll see a silt layer. And in 30 minutes or up to a day, you'll see a clay layer. And then you're going to take a ruler, and you're going to measure the height of each of the layers over the total height of all of the layers after a day. And you're going to multiply it by 100, and you get a percentage. And that will give you the sand, silt, clay proportion that you then use to look at this triangle right here, right? So you'll have the percentage of sand, silt, and clay, right? Sand, silt, and clay. And you're going to use that ruler and follow your line. So let's say you have a 40% sand, right? And a 40% clay here, right? And then a 20%, I'm sorry, 40%, yeah, clay there, and then a 20% silt. So you're getting towards a sandy clay loam, right? And that will give you an understanding of how well air and water will flow through the soil. Thanks. Next.
Okay, another question came through. Would you recommend removing large rocks from topsoil or leaving them be?
I use a quarter. You know, if you have something larger than a quarter, think about whether the plant's roots can grow around it. Having some rocks, a little bit, as long as it's not the majority of the matrix of the soil, rhizosphere, that area in which the roots are growing, right? The rhizosphere. You know, having some rocks is okay. It allows for some drainage. It also allows for some worms and other microorganisms to accumulate there a little bit as well.
Those are all of the questions I've seen in the chat. Mishwa, I think your hand is raised, but I think it was from the beginning. I just want to make sure if you want to talk and ask a question. Like, okay. I don't think she did have a question. I just wanted to share a little bit about, Rob mentioned some of the stuff I was adding in the chat. So there's a resources document that has links to a few different documents for further soil reading and learning. So I definitely recommend clicking on that so you can save it before we close out tonight. And then we also, I put a link to a survey. It's a really short Google survey. It's the Post survey. So when you registered for the workshop, there were some questions about your understanding of soil health and soil indicators and soil quality. So this will be the kind of post workshop evaluation to help us get a sense of how we did and so we can improve for future workshops. And then I will also put my email in the chat for any of you who are interested in reaching out about any of the technical assistance we can provide. So feel free to send questions, or if you'd like to set up a site visit, I'd be happy to do that. Or if you just have questions about the RCD or want to chat about soil health, or yeah. So I will add, my name my email in the chat, and we can stay on for a few more minutes if anybody has any other questions. And a reminder to register for the August 3rd workshop. I added the registration link in the chat also. Rob, do you have anything else you wanted to add?
Sure. So simply put, don't forget to regularly add compost every time you plant and you harvest. A little bit at a time helps a long way. And your responses to the surveys actually help us to improve on the quality of the webinars or the workshops, and help us ultimately to provide data to the funder that supported this program effort and keeps these webinars free or low cost. So thanks so much for completing that survey. That's really important. We really appreciate you.
And I also wanted to thank Rob for offering up all of his time to talk tonight and prepare for tonight's workshop. So thanks, Rob. And this was recorded, so we'll share the recording to those who registered and attended if you want to watch it again or share it with your friends. And
thanks for coming.
Yeah, thank you so much. I think that's it for now. And we look forward to seeing you on August 3rd.
Take care, everybody. Bye-bye.
Bye.